So we will start in 3 minutes.
Yes.
Okay, so good morning, good afternoon, and good evening, dear participants from all around the world. Welcome to the beginner group training for atmosphere protocols. This training is intended for the discussion of the following protocols: clouds, air temperature, relative humidity, and precipitation. So let's get started. Allow us to introduce ourselves, your speakers and trainers for this group. My name is Josephine Joy Tolentino Antalan, Special Science Teacher and Biology Unit Head of the Philippine Science High School Central Luzon Campus, located in Clark, Freeport Zone, Philippines. I am a Globe Master Trainer since 2018, and I have been a member of the Globe Diversity, Equity, and Inclusion, or the DEI Task Force, and participated in the in-house training in Boulder, Colorado last February 2020. Together with me are Ulay and Jessica. Ulay?
Hello, everybody. My name is Lekikas. I am an atmospheric scientist and PhD in environmental physics. I have been in Globe since 1996 and have been 10 years as a Globe country coordinator in Estonia. Jessica?
Hello, it's a pleasure to be with you today. I'm Jessica Taylor. I am an atmospheric scientist at NASA Langley Research Center, and I joined Globe as a student in 2000.
Thank you, Ule and Jessica. So, dear participants, here is the overview of our activities for today's training. We'll start, of course, by a quick introductory questions in order for us to know our participants. Then we'll proceed to the first topic, which is about clouds, to be discussed by Jessica. After which, I will be discussing about data entry, including Globe Observer app, and sharing of my training experiences. Lastly, the third topic is about air temperature, relative humidity, and precipitation protocols, which will be discussed by Ole. Finally, we'll have a wrap up later, and if we still have time, participants can ask questions to any of the speakers. However, we would like to remind everyone that we have a protocol question and answer session on Thursday, July 15 from 9 o'clock to 9:45 a.m. Mountain Daylight Time. By the way, Jessica has sent the Globe Beginners Protocol session reminders last July 9, and we hope that everyone was able or has tried to accomplish the needed trainings before this session. So there, let's start our training proper. Let me first ask you to answer this question. From which globe region are you? So if you have your mobile phone with you, kindly scan the QR code in your screen. Please let me know in the chat box if it's working on your mobile phone. Okay, so let's give another few seconds for the participants to answer. Okay, let's see the results. Okay, so can you see my screen? Okay,
Yes.
so we have two participants who answered North America. Okay, so we're still waiting. Probably the other participants will be answering later on during our discussion. Okay, so we have other participants from Latin America and Caribbean region. So welcome to our training. Okay. Okay, so let's get started and move on. Thank you again for your participation in the first question. From which globe region are you? Let's start with the first topic. So the first topic is about the cloud protocol, which will be discussed by Jessica. So Jessica?
Yes, thank you very much. And I am part of the North America region. And I do want to remind everyone that this session is being recorded. Go ahead to the next slide, Joy, please. So if you could use your phone again and scan the QR code, we would like to know how you say cloud in your native language, your original language, or your dialect. As you can tell, we're going to be using our phones a lot to do this. Nice. So I put in nubes. Ule, is that from you? Is the other one your native language?
Mine is ulap.
Oh, okay, wonderful. All right, let's go back to the slides. So one of the things that's really interesting about clouds is that we name our clouds, and each different cloud type has its own name. So I'm going to put in the chat box here, I'm going to put a link to the most recent cloud chart. And the globe cloud chart, um, the names of the clouds have not changed over the years. It's just the format of the cloud chart itself. So in the chat, if you would please respond with what cloud type have you seen today? And so this morning, I walked my kids to school and we had cirrus clouds up in the sky, which are the wispy clouds that are very high, made up of ice crystals. One of the things I would like you to notice in this new cloud chart is that we have organized the clouds in that if you look on the leftmost side of the cloud chart, you'll see a lot of the stratus clouds. And as you go up, you see the naming convention changes from stratus at the low level to altostratus to cirrostratus. On the right side of the cloud chart, we have cumulus clouds. These are the puffy clouds that happen because of convection. And these clouds you'll see at the low level cumulus, altocumulus for mid level, cirrocumulus for high level. And it's great. We've seen some cirrus, we've seen some cumulus, and we've even seen some contrails, and you'll see those contrails going across the top. So hopefully this cloud chart helps you in identifying the different cloud types. And what I like to remind people is when you're thinking about learning about clouds, is it's not just important to know the cloud type. The cloud type is telling you about the properties of the cloud. What and how it was formed is very important to understanding what's going on with your weather. Next slide, please. So why are clouds important? Well, they're certainly a part of our weather, but they're also very important parts of how energy cycles in our Earth system. So clouds are an important part of both the water cycle and Earth's energy budget. And these are two very important things for students to learn about. And clouds play a very critical role in the water cycle in terms of having the water evaporate, condense to form clouds onto those cloud condensation nuclei, and then precipitate maybe. And then in the energy budget, the important thing to note is that not all clouds act the same way in the energy budget. Some clouds actually cool the Earth overall, and some clouds warm the Earth overall. And so it's not just enough for us to know that there are clouds out there. We want to know more about the cloud. What type of cloud was it? What was its opacity? The opacity question in the cloud protocol is asking you about how much sunlight passes through the cloud. And that's an important part of its energy budget impacts. Next slide, please. When you make a cloud observation, the more details about clouds that you document, the more useful your observations are to researchers. And so in this table, this is indicating that for the cloud protocol specifically, there are actually only two things required for you to submit, and that's your total percentage cloud cover and what your surface conditions were. You can think of surface conditions as looking the satellite image from above. But we really want more information, right? And so we need to know what type of clouds were out there, what levels they were at. And as I mentioned, opacity is very helpful in helping us understand the impacts of energy budget. So we encourage you to do as much observation as you possibly can in the cloud protocol itself, including submitting photos if you're able to. Next slide, please. So something that we notice people get confused by is the question of obscured versus overcast, these terms, obscured versus overcast. Well, an obscured sky means that at least 25% or more of the sky is actually blocked by something other than clouds. In other words, you can't see what the cloud types are because there's something in your way. And that something is typically something like dust, haze, blowing sand. And this is blocking your ability to even observe the clouds. So that's obscured. An overcast sky, on the other hand, is the term that we use to talk about the percentage of cloud cover when the clouds are covering the whole sky. So sometimes this can be tricky when you have something that's obscuring your sky that looks more like a gray or a white material. But try to think about this when you're making your observation, that obscured is blocking the clouds versus overcast being a description of how many clouds there are in the sky. Next slide, please. So a common question we get is, when do you observe clouds? Well, cloud observations can be made anytime, including your solar noon, or if you want to match it to the satellite overpass. And in the Globe Observer app, there is an orange button there that says check satellite flyover. And you can find the time when satellites that are observing clouds, like NASA's Terra, Aqua, or Calypso satellite, are overhead. And you can time your observation to that, so that way it's extra helpful to scientists that are using the satellite data and for your own investigation. Next slide, please. Well, we have also begun matching to geostationary satellites. So the satellites on the previous slide are polar orbiting satellites. They go around from pole to pole. Geostationary satellites are farther away from Earth, but they go with the Earth. So they're basically stationary over the same spot of Earth. And at the Globe Clouds team, we match to multiple geostationary satellites around the world. So really, almost any time of day, you can go outside and get a satellite match from your geostationary satellite, and we will email you at NASA Langley. That's our job, is we email you a comparison of what you saw versus what the satellite measured. Go ahead, next slide. A new web page that we just released recently is Specialty Observations. Specialty observations provide an opportunity to contribute data to a scientist's specific research question. And this is important also in thinking about when to observe, because some of these have a time that we're looking at. So there's several of them listed here. Cloud Gaze, Zooniverse is brand new, our partnership with Zooniverse. Measuring contrails is very important because that is something that a ground-based observer of clouds can see basically better than satellites. Dust is very important. Aerosol related things like dust, but also sky color and visibility. And then something else that we've been talking about is solar terminator, the time in which we change from a satellite perspective from sunlit to dark. In other words, sunrise and sunset. So if you were trying to contribute observations to solar terminator, you would be making observations at close to sunrise and sunset. And you're welcome to take a look at that website later on. Next slide, please. So I've put together a number of resources for you, and you don't need to write these all down. At the end of our session, we're going to email you. You should have received an email from me already, and I'm going to email you a link to our Google slide presentation so you can have access to all of these links directly and the slides that we just said. So make sure to check out our new science videos. We have a student project support page, help with satellite comparison, and then of course, don't forget your e-training. Now I'm going to pass it off to Joy.
Thank you, Jessica. Hello again, dear participants. So today I'm going to discuss about entering data using the Globe website and the Globe Observer app. But before we start, let me ask you first. Which Globe protocols in the Observer app are you familiar with? You may type in your answer in the chat box. Is it Globe Clouds, Mosquito Habitat Mapper, Land Cover, or Trees? So which of these protocols in the Observer app are you familiar or have you tried using? So we have responses, land and trees. Okay. So we have clouds and land cover. So thank you for your responses. So let me start by discussing the data entry in the Globe website. So there are numerous ways in order for you to log on your measurements in the Globe databases. You may use your mobile through the Observer app, using the Globe website, or via email. So the Globe's databases are freely accessible to everyone. You may check out these protocols or even find demonstrations of data analysis tools. Using the Globe website, you can actually access or do the following. So we have data entry, visualize data, retrieve data, Globe API, Globe Data User Guide, Science Honor Roll, and data tutorials. So in entering data using the Globe website, we have first data entry. So in Globe data entry, anyone can log on their measurements into the Globe repositories in a variety of ways. The Globe data entry methods include live data entry, training data entry, email data entry, and the data entry mobile app. You can visit globe.gov for more information about the data entry and find out the best ways or the most suitable entry method for you. Then we also have the visualization of data and retrieval of data, which I will be discussing in the next slides. So in visualization of data using the Globe website, the Globe program has this visualization system, or the VIS, which can view, graph, and export Globe data from around the world. You can do so by entering the Globe's visualization system using the link vis.globe.gov. In order to know about how the Globe VIS works, please watch out this short video clip. Okay, so it's your turn to explore vis.globe.gov. So another method that you could do with the data of the Globe website is to retrieve them using the Globe Advanced Data Access Tool, or the ADAT. So you could use this link, datasearch.globe.gov. So in ADAT, you can find and use the data that you are interested in and even refine your search using various parameters, and then choose specific sites that contain the measurements you are looking for. These specific parameters include protocol, date range, date count range, site name, country, state, or territory, proximity to lakes or rivers. You can also search for the school, teacher, or partner, elevation range, latitude and longitude range, and proximity to latitude and longitude range. So once you have chosen the site that you want to investigate, you can now apply more filters to narrow down your data search or download the data you are interested in. How cool is that? So the ADAT also includes the option to download all the summary file that compiles the amount of available data for each site of interest. So why is this important? This feature of ADAT can be used to further evaluate which sites are rich in data and those that need further investigation. So here are some of the features under the Globe data that you can access in the website. So we have the Globe API, which was built to support developers who would like to retrieve data from Globe in a programmatic interface. Then we also have Globe Data User Guide. So this one is a page dedicated to help scientists and researchers understand, access, and use available Globe data. So this one includes data collected from Globe-trained teachers, students, and citizen scientists. So we also have Globe Science Honor Roll, which recognizes the data contributions of students and schools from time period. And lastly, we have the data tutorials. So this is where the resources are uploaded, as well as quick tips in data entry. So for the last part of my talk, let me share some of my training experiences with high school students and teachers in the Philippines. So I have been conducting student trainings and teacher trainings before the pandemic. So these trainings are conducted from urban areas to rural and far-flung areas and islands in the Philippines. So our usual problem that we encounter when we have our training is internet connectivity. So I remember in one of our training, participants have to travel for about 3 to 5 hours by boat just to get to the venue. And of course, even though we have sent them pre-event instructions to their email, the internet connection is still very bad. So our group had alternative options, which is to bring iPads with pre-installed Globe Observer app and laptops that the participants could use. And of course, we brought our own Wi-Fi using a broadband or cellular data from our mobile phone. So tip number 1, expect the unexpected. So be prepared to possible problems or challenges that may come up in your training. We also have one instance when we were in the middle of the training, then suddenly there was a power outage. So this is beyond our control. So we managed to continue our training with activities that do not require electricity at the most. So we have thought of asking the participants, so these are teachers, to have sharing of best experiences. So what are the best activities or the most interactive games about cloud protocols, for example, for their students to be shared by other teachers or to be shared to other teachers. So tip number 2 is to prepare also for alternative solutions. So in case, like for example, in one of our trainings, students need to take pictures of clouds using the Globe Observer app, but then it was raining so hard and we can't go out. So we have prepared alternative solution, which is we printed worksheets for the students to answer and discuss with their group mates. So the last tip that I will share to you is begin with an end in mind. So I think this is the most important thing to consider. Participants can enjoy and apply the learnings they have with your training, no matter what challenges or problems you have encountered along with the way. So always hit your target goal. So that ends my part of the talk. I will now be giving the virtual floor to our last speaker, who will be discussing about related atmosphere protocols.
Hello again, dear participants. In the last part of our session, I will introduce shortly the related atmosphere protocols. Atmosphere is very important for us in every day, since we all depend on weather conditions. To describe weather in your place, please write, next slide, please. Please write in chat what was outside air temperature in your place yesterday around local noon. Oh, 90 of Fahrenheit. How much it is in Celsius? Ah, 32 of Celsius, or 35 to 40 degrees of Celsius. It's hot everywhere. Next slide, please. We will shortly go through the air temperature, relative humidity, and precipitation and rain protocols. All those atmosphere measurements you can do at your school, in your study, atmospheric study site, or of course, when you need the atmospheric data to support other globe investigations. Please, next. In your study site, you should have the instrument shelter and also install the rain gauge for collecting rainwater. Next, please. Let's start with the air temperature. Air temperature is very important for our everyday life. How cold is outside, how hot is outside, what I should wear today. But air temperature is extremely important also for atmospheric science. Because most of the atmospheric processes are depending on air temperature. Next, please. The air temperature protocol and other atmospheric protocols are very often the protocols what the globe schools start to do as first globe protocols. And the air temperature protocol itself is quite easy. Students should take the temperature measurements every day, daily, within 1 hour of local solar noon. Of course, they should know when is a local solar noon in their place. And then take the reading of current air temperature and read also the maximum and minimum air temperature for previous 24 hours. Here is important to pay attention of students that when they forget to reset indicators of maximum thermometer, they cannot take the valid maximum temperatures and send to the globe database. You can use different types of thermometers as globe measurements instruments, automatic stations, digital thermometers, or traditional liquid thermometers. And I would recommend to start the temperature measurements, especially when you start with younger children, with a traditional liquid thermometers. Let students to study how the max min thermometers work, train reading of scale and taking temperatures with the accuracy of half degrees of Celsius. This is quite a big challenge for beginning. Next slide, please. As a part of every training, we would ask the questions from you, and please go to the poll and answer this question. You can scan the QR code or to copy the link in your computer. Joy, can you comment the results? Mm-hmm.
Okay, so we have 25% who answered yes and 75% who answered no. So let's see the correct answer.
Yes, the correct is no, because when you have measured the, when you have not resetted the indicators, then you don't know for how many, for how long time this minimum or maximum temperatures are valid. So you can take the min-max temperatures only when you have reset it 24 hours ago. Thank you for answering. And let's go now to the relative humidity protocol. Water plays extremely important role in the planet of Earth. It moves between Earth's spheres. Water evaporates from land and water bodies and gets into air because of transpiration from plants. When water vapor moves up and cools, it condensates into water droplets, which can form clouds. When cloud droplets became large and heavy, they fall back to surface as precipitation. Those processes of water cycle are strongly influenced by temperature and relative humidity of air. Understanding of relative humidity helps us to understand the water cycle and movement of the thermal energy in the atmosphere. And the concept of relative humidity is not an easy one, because there are two indicators of the water vapor content in the air. First is what we call the specific humidity or water vapor content, which is the actual amount of water in grams per air cubic meter. And then is a relative humidity, which is a percentage of water vapor compared to the maximum amount of water vapor that the air could hold at this temperature. Relative humidity depends on temperature. Warmer air can hold more water vapor than colder air. And the saturation point is in the warm air is higher than in cold air. When there is the same water vapor content in the warm air and in the cold air, the relative humidity of the cold air is higher than the relative humidity of the warm air. It actually means that less water vapor can be enclosed into cold air before the saturation point appears. In the near surface area, we can sometimes observe the phenomena like fog and dew. They appear when cooling of air, which is already has quite high relative humidity, causes the increasing of relative humidity and the water droplets can form when the relative humidity becomes until 100%. Please, next slide. Just to check what you already understand about the relative humidity, please answer the next two questions in poll. So it's
So all of the participants answered option letter B, decreases. So let's see the correct answer. So that's the correct answer.
Thank you for the nice correct answer. Please now the next slide.
So here's the second question. Please answer using this QR code or using the link.
Yes.
Okay, let's see the responses
Yes.
and the correct answer. There.
Are dew and fog. Because it's a phenomena what appear in the near surface air, not high in the atmosphere, where cloud droplets are appearing. So please, let's go to the next slide, which is about relative humidity protocol. You can use different types of instruments for measuring the relative humidity. One possibility is to use digital hygrometer, which is quite an easy to use. But another possibility is to use sling psychrometer, which I would recommend to use at least for some training of students, because measurement with a digital hygrometer, measurement with a sling psychrometer is fun for students. And in addition, understanding this measurement method helps to understand what relative humidity means and how it works in the energy budget, in the energy terms. Please please go to the next. So the sling psychrometers may look differently, but they are always compiled from two thermometers. One of the thermometers has dry bulb, another one has a wet bulb with a wet wick around the thermometer. And let's see a short video about how to work with a sling psychrometer.
This is a basic instrument. It looks fancy, but all it really is two thermometers. Two thermometers that are on this swivel, and that can be spun in the air like this. Doesn't it look like fun, right? The difference between these two thermometers is one of them has a claw tied around the end of it, and that's called the wet bulb thermometer because we get this wet with room temperature water, okay? It should have some moisture in it. The other one we call the dry bulb temperature because it should be, or the dry bulb thermometer because it should be dry, right? What happens is when we spin a sling psychrometer in the air, any water on the dry bulb temperature, I'm sorry, there should be no water on the dry bulb temperature thermometer, but any water on this wet bulb thermometer should start to evaporate and go from a liquid into a gas. And when it does, it's going to pull energy from this thermometer. Very similar to how sweating and then the sweat evaporating off your skin causes your body temperature to drop. So as I spin the sling psychrometer, the temperature of the wet bulb thermometer will start to drop. And the dry bulb thermometer should stay the same. It should be unaffected by the spinning because the only thing that's changing the temperature is evaporating water off of the wet bulb temperature, right? What this gives us when we stop and when we read the actual thermometers, it gives us two temperatures. You should get one temperature for the wet bulb thermometer and one temperature for the dry bulb thermometer. And if there is any evaporation that takes place at all, those two temperatures should be different. The wet bulb will drop lower and the high bulb will stay as the higher temperature, okay? There is one instance where you can sling this all day and the temperatures will stay exactly the same. They stay the same if there's no evaporation happening here. And the only reason that no evaporation would happen on the wet bulb thermometer is the air is already totally saturated, 100% relative humidity. At 100% relative humidity, these two temperatures will read exactly the same. But in most cases, they won't be the same. All right? So when you come back to class, we'll teach you how to use
Thank
this
you.
slide rule here in the front to
You
figure
can
out what
close
those
the video. I think we will not look at it until the end. But please, participants, go to the next question of the poll and answer, please, the questions about the psychrometer, sling psychrometer. Good. And the right answer, of course, is the wet thermometer, because when we twist the wet thermometer, the water evaporates and takes the energy from the thermometer and brings into air as together with the water vapor. And the next question is also about the sling psychrometer. What was wrong with the measurement when after twisting the sling psychrometer, the both temperatures showed again the same temperature?
So 100% of the participants answered option letter B.
Yes, but it can be also that you simply have forgotten to make the wet bulb wet, so there was no water in the wet bulb, and of course no evaporation took place. So such things could happen when you are working with students and when they are doing measurements. So it was some funny question about this. And as next, please go skip some slides and go to the slide 41, which is some kind of, no. But we don't have time a lot, but still let's tell shortly about some issues which can be, which are important together with the rainfall protocols. The rainfall protocol require more attention than other atmosphere protocols, since rainfall is irregular in time and amount of rain strongly varies. So students should, it's the best when students check the rain gauge daily. When they check it over several days, pay attention that they always record the number of days during which the rain was collected. Otherwise, you cannot get the valid data for globe. Also, pay attention that students measure all the rainwater collected in the measurement tube and in the overflow container, which should be always around this measurement tube. And also pay attention that all the rain from the rain gauge is put to the another closed container, which you take into lab for making rain pH measurements. And as a conclusion, please go to the slide 41. My comment about the globe atmosphere measurements is that those are daily regular measurements, and sometimes it could be like boring for students, but try to awake curiosity of students, give them interesting tasks to find solutions using the globe data. Encourage students' teamwork so that the whole class is somehow included or engaged with globe measurements, and challenge them for doing research projects using globe data. Give them opportunities for sharing their research results and discoveries. So, and try to make measurements meaningful for students. Then they want to do it and are happy to be the young scientists. So, Joy, can you now follow?
Thank you, Ule. We wanted to leave you with, I guess, a satellite image of inspiration. Of course, working at NASA, we use satellites in space to get this global view. And thinking of the GLOBE program and the number of participants internationally in this program, we can see from this image from space why understanding Earth and making measurements is both a local to a global issue. And so this is a satellite image of its modeled cloud cover. You see a little bit of purple and teal. Those are aerosols. And what I find beautiful in this video is that you can see that things that originate in one location travel to another location. And hopefully you were able to see in understanding the atmosphere, there's a lot of different components. And we only spoke about the atmospheric protocols, but Ule mentioned on her slide too, how you could bring in components of pedosphere and biosphere in your investigation of atmosphere and start thinking about it from an Earth systems perspective. The link to this video will be in the slides when we send it out. And I'm going to pass it off to Joyce for some final words.
Thank you, Jessica. So thank you for your attention and interest in the globe atmosphere protocols. Now, we still have 3 more minutes, so maybe we could entertain 1 or 2 questions. If you have, please type in the chat box. And We would also like to remind everyone that we still have protocol Q&A session on Thursday, July 15 from 9 o'clock a.m. to 9:45 a.m. Mountain Daylight Time. So we hope that you have enjoyed and learned something from our training. So if you still have time, kindly tell us your training experience at this QR code, via this QR code, or respond at this link. And we're still waiting if you have some questions.
Joy, would you go ahead and advance the poll everywhere to that final question? It's still showing our last relative humidity question.
Okay, sorry.
No problem.
So please describe your experience today in this beginner training for atmosphere protocol. So you could use maybe one word or two words to describe your experience for today's training. Okay, so thank you everyone for participating, and we hope that you have learned a lot. Enjoy the rest of the week for the Globe Annual Meeting. So we have been your speakers. I am Joy Tolentino, and we have Ole and Jessica.
Thank you very much.
Thank you for looking us.
Bye, everyone.
Okay, I'm going to end the meeting now. Thank you so much. I actually learned quite a bit. I enjoyed it.
Thank you so much.
Thank you, Tara.